It's either in the morning at 8:30, so you get there at 8, or it's at 11:30, so you get there at 11. Yeah. Okay, so right here. So today we're going to talk about normal distribution, what normal distribution is. Normal model is considered a density curve for these two reasons. Because the area is always one whole, and because it's above the x-axis. So it means the area is positive. If those two are met, then it's a density curve. Okay? So all of these guys are density curves. All of these guys, all four of these guys are density curves. Some of them don't even look like curves, but they're all positive. And if I found the area, it'd always be one whole. Okay? That's why they're density curves. Okay, so they can look differently. The ones we're going to focus on look most like this, or like this. That's the one we're going to focus on for the rest of the chapter. Okay? Those are called normal. It's not normal like the word normal, like average or regular. It's not normal. The reason normal is capitalized is because the person who found normal model, his last name was actually Normal. That's his last name. So that's why we always capitalize normal. Okay? So that's why it's always capitalized, because it's not because of it's a name. It's actually the name of a person. It's his model. Okay. Now, why is this important? We just took a test. How many people would like the test to be curved? Everybody should raise their hand, right? Because curving only helps you, right? And I did curve it a little bit. Mr. Normal is the one who came up with curve tests. Before him, there were no such thing as curve tests. Okay. Yeah.
Is there like another mathematical name for this type of graph? Otherwise, for a model, it's going to get confusing if every time it's going to be like normal. Even though it's a name of the guy who made it, it's going to be like thinking, okay, this is what a normal graph would look like.
The way I have students remember it is that just kind of looks normal, right? It doesn't look like that guy. Doesn't look like those guys look weird. To me, these guys look, maybe I've been teaching this class too long, but these guys look weird. One's a box, one is skewed to the right, one is skewed to the left, and one is like, yeah, I don't know what it is. I don't even know what that is, right? This one just looks very nice, very normal, right? It goes up easy, it peaks in the middle, and goes down easy. That's why I ask my students to say, if they say, how do you memorize normal? How do you look at normal? That's how it looks normal. Okay. We're going to be doing so much work with normal distribution that memorization won't even be a problem. Yeah. You guys will be doing so many problems like this that it's not even going to be worth it. You're not even going to be second thought. Okay. So first we're going to use the data I had from a couple of years ago, and then we'll bring in your data. Okay, so first I want to do this because I want to go through it using this data, and then we'll bring in your data, and you guys will do it on your own. Okay, so this is the data I had my students do this. Like I said, 3 or 4 years ago, before COVID, I had them do the exact same thing you guys just did, and then they did the exact same thing. They took a picture of the QR code, they put it in there, and boom, they have it. Okay, so these are their heights. Very similar to your guys's. Very similar to your guys's. Okay. I think this class was a little bigger, but besides that, more numbers. Okay. My question is, are these normal? Are these normal? Well, to figure that out, so if I were to graph these things, if I were to put these things in L1 and do a histogram, would my picture look like this? That's what I'm pretty much asking. Would it look something like this? Or would it look something like that? Or like that? Or like any one of these guys? Probably not like this, because no, that doesn't mean everyone's the same height. It means there was an equal distribution of everyone. So there was the same number of short peoples as there the same number of tall people as the same number of medium people. The way populations work, it doesn't go that way. Most of us on Earth, or in the United States, or even on Earth, are somewhere in the middle. There are some extremes, right? Really, really short, really, really tall. But most of us, so most heights, if I were to take the height of everyone in the world right now had all 6 billion of us, and then we were to graph them, they would look almost identical to that. And the middle would be for men, the middle would be about 5'9", and the middle here for women would be about 5'5". Now, does that mean everyone is? But no, it just means the majority. It just means the majority of people are somewhere in the middle. Okay. Same thing with IQs. IQ score. You guys know what IQ scores are? What are IQ scores? Some of you guys take psychology. So what does that mean, intelligence? What does that mean? People are like, I'm intelligent. What does that mean? What is intelligence? What is intelligence? It's part of it is seeing patterns. Yeah. Some people think I can solve those equations on the board. I'm intelligent. You might be, but it doesn't necessarily mean you're intelligent. I know some very intelligent people who don't do those, right? And I know some unintelligent people who probably could do those, right? So what it says is your brain's capacity to learn. How much can your brain hold? How much can your brain process, right? That's what intelligence is. So they gave my son, who was in first grade, an intelligence test. I'm like, well, he can't, he can barely, he's doing very low level stuff. How do they do it? Well, it's kind of like, do they recognize patterns? Are they critical thinkers? Are they, they test them like that. So intelligence is how much can you process? How quickly can you process? How quickly can you learn? How quickly can you go through everything? It's not a math test. It's not a reading test. If you were to look at an IQ test, it's got a lot of shapes on it. They'll be like, what shape comes next? What's the pattern? They'll be like, look at this pattern. Which one is stands out? Which one? It's questions like that. You're just kind of like, what? This is not math. This is not English. This is not history. No one talks about World War II in the IQ test. It's because how much your brain can hold. Okay, that's an IQ test. So the bigger the IQ, it means you can process more things and more things fast. The lower means you can't process things, right? You can't. It means the ability to, even if you wanted to, you can't, right? Most people are somewhere in the middle. The average IQ score is 100. So most people are around there, right? But then the higher you get, the more intelligent you are. The farther away you get, the less intelligent you are. Okay? So it just depends on your score. But that's what an intelligence test is. That's what an intelligence test is. If I were to give everyone in the world an intelligence test, that's what it would look like. Most people would be somewhere around the middle. These two high bars would probably be 90 to 100, 110. So some people are right at 100, a little bit above 110, a little bit above 100, a little bit below 100. Okay? Obviously you got your brain, you got your very, very intelligent people over here, right? Not a lot of them. Not a lot. A lot of people think they're over here, but in reality they're not. Most people are not over here. Okay? Most of us are somewhere in the middle. Most of us are somewhere in the middle. Everyone, in America, everyone wants to think I'm the best, I'm the greatest, I'm the best, right? My son thinks he's the greatest, thinks he's the best at everything he does, right? But the reality is most of us are somewhere in the middle. Okay? There's nothing wrong with that. There is nothing wrong with that. Okay? But yeah, so those are the types of things that are normal. Okay? Okay, so how do we know if these heights are normal? There's three things we got to check. The first one, I think it's on the back of that page or the next page. The empirical rule. It's called the empirical rule for checking normality. Okay? So, for it to be normal, 68% of the data, 68% of the data has to be between. So let's look at these. Let me write these. No, you guys already have it in your notes. So these symbols, there's going to be a lot of symbols down here. Remember these symbols? I had them up yesterday. I put them on here. These symbols, right? You're going to see a lot of these symbols. X bar means the sample mean. Mu of X means population mean. Sigma of X means population standard deviation, right? I had those on the board yesterday. I put it on the notes, so they're on Google Classroom now because I had to erase it for my next class. Okay, so you know those, right? So let's go back into this guy here. Right here. So 68% of the data has to fall between, in the green stuff here in the blue, mu plus sigma. What does that mean? What? Add one what? There you go. The mean, whatever the middle was, plus one standard deviation. Okay. Now, what's the low part? The mean minus one standard deviation. Whatever those are, 68% of the data has to be between there. Okay. That's the first condition. The second condition, 95% of the data has to come between two standard deviations above and two standard deviations below. 95, almost everybody, right? Almost everybody. And then the last one is the 99.7. The 99.7 between three standard deviations above and three standard deviations below. Okay? These are three conditions for normality. Three conditions for normality. So to be considered normal, you have to match all three of them. Okay? Or come pretty darn close. What do you notice about 99.7? It's very close to 100. Why didn't they say everybody? Why didn't they just might as well be 100, right? 99.7. That means if I had 1,000 people, three of them would be 0.3%. Why didn't they just say 100% and say 100% of observations have to be within three standard deviations?
Does that be inaccurate?
What's that?
Does that be inaccurate?
Why not? Why would it be inaccurate?
Because you left some space far right and far left.
Yeah, so why couldn't I color the blue? That's what I'm saying. Why couldn't I color these guys in with the blue? The very ends. Why couldn't I just say, you know what? 99.7, let's just color in this in with blue. Why couldn't I do that?
That's inaccurate data.
There you go. Possible outliers. We could always have outliers. We could always have outliers, right? Now, is there going to be a lot of them? No, but we could have outliers. We could have people that fall over here. We could have people that fall over here in society, right? If you watch an NBA basketball game, you're watching a bunch of outliers. Now, they don't look like outliers because they're all with people their same height. But guys that are 7'4" don't walk around, right? I have never seen someone in real life that's 7'4" inches tall. But if you go to a basketball game, you will. And you'll see his buddy who's 7'4". And you'll see another guy who's 7'4". And you're like, wait, there's a lot of but they don't exist. You're not going to see anyone that tall, right? So sometimes you get kind of jaded and you say, well, I went to a basketball game and I saw, or my buddy on the basketball team's 6'8". Yeah, but they don't exist out there, right? They don't exist. There's one for every one of them. There's 1,000 who aren't 6'8". So those guys are outliers. Those guys are way out here, right? Just like on the short side too, there are people that are really short, right? You don't see a lot of them, right? But there are people out here. If we're talking about heights, okay. So those are the three things that have to occur for us to be considered normal. So the first thing we're going to check is this guy right here. We're going to check this guy right here. So the two things we need to know are three things. What is the mean? What is the standard deviation? Those are the first two things we need to know. We can't do the third thing unless I have those. Okay? So let's go back to our data. It's written on your paper. It's also written up here. What's the mean and what's the standard deviation? That's the first thing I want you to do. Okay?